all of chapter 1 actually is a lot of vocab. So there's not a lot of arithmetic. There's not going to be a lot of algebra in this stuff. This is all a lot of vocab. So it's weird in geometry, but we have things like Quizlets to study. You literally have to read things. It's a little bit different than algebra, okay? And there's a lot of vocab. So chapter 1, section 1 is called Points, Lines, and Planes. A point is a single dot. It is the simplest figure in geometry. And it is named by a capital letter. All geometric figures consist of points. If we were talking about dimensions, a point has no dimension. So if it had said, what's a one-dimensional thing? That's like a line, okay? A two-dimensional would be like a plane, something that has length and width. And it sounds weird because it's like, how can something have no dimensions? But it doesn't continue in any direction. It's just a single point. So a point has no dimensions. So on this screen, you'll see that dot. That is point A, and the dot, and that is point B. And it will either just say A, or it will say point A. And those mean the same things. So a single capital letter by itself is describing a point. Questions on point before I go to the next slide. All right, a line is a geometric figure consisting of at least 2 points extending in 2 directions without ending. So a line has no end, which means it cannot be measured. If there are arrows at the end, I cannot ask you how long it is because you don't know when it stops. It is named by 2 points or a single lowercase letter. And through any 2 points, there is exactly 1 line. So any 2 points given in any direction, you can only draw 1 line, but a line must be drawn. So exactly 1 means no more and no less. The diagram that's there, you've got a line, and it has all these different names. I could call this line AB with the word line. I could draw a line over AB. I have to have 2 arrows on it to describe a line. Or I can call it the lowercase italicized L that's there at the end. So all different ways and all correct ways to name a line. A line has 1 dimension. A plane is suggested by a floor, wall, tabletop. So if I were to give you a visual representation of a plane, I could literally say, look at the ground. The shape on the ground is a plane. An individual tile on the ground could be a visual representative of a plane. This desktop could be the representative of a plane. This iPad could be a representative of a plane. They all have length and width. They all go in 2 directions, okay? But that's just a representation of a plane. In reality, planes never end, which means this is just part of the plane. Even if we don't see it, it is technically extending in all the directions, left, right, forward, back, okay? So if you could figure, like if you could picture a floor that never ends, that big, huge floor, that is a plane. It would never end, which means we cannot also measure the sides of a plane. I can't say how long is the side of the plane because it never ends. It's made of lines, okay? Although it has no edges, like it's shown in the picture, you will see the edges, obviously, because your picture can't be something that doesn't end. And it's named by a single capital letter or 3 or more points it contains. So I can either call that diagram plane M. I can call it, like if this was point A, and this was point B, and this was point C, and this was point D. I can actually call it ABC. I could call it BCD. I could call it CDA. Any of those would be the same, okay? You're describing the same plane. Not M, because M is not a point on that plane. M is the name of the plane. But any of those points on that plane I can use, any 3 I can use to describe the plane. You could also call it ABCD. It's still a plane. And a plane has 2 dimensions. Do we end? Okay, space collinear, and coplanar. So a space, or the space, is the set of all points. Collinear is defined as points that lie on one line. Non-collinear do not lie on the same line. Coplanar, points on the same plane. Non-coplanar, points not on the same plane. So if I were to draw a plane and I put A, B, C, D, E, somewhere floating in the middle, okay? All of those points would be coplanar because they all lie on the same plane. A, B are collinear. B, C, C, D, A, D. Any 2 points are going to be collinear because you can connect them all. But something that would be like, so A, B, and C are non-collinear. A and B might lie on the same line, but C does not. So even though 2 are collinear, if that third one is not on the same line, we would say they are not collinear. And if I drew, let's say I draw a plane that's running vertically, like it's the side of the box and the bottom of the box, then M, D, and C are not coplanar. All right, a segment or a line segment consists of endpoints. So a segment has a stop and start. All the points that are in between A and B would be said to be on segment AB. So by definition, what's the difference between a line and a line segment?
A line segment has an end.
Okay. How about, can we measure a line length? A line? No, it doesn't end. Can I measure a segment?
Yes.
Yes, it ends. All right. And then pay attention to the way that this one's written. So notice that there's no arrows over the AB. That's how I know it's segment. A segment is also known as just 2 letters. So if I write AB without anything over the top of it, that is implying segment AB. So nothing over the top means segment, not line. The line has to have the arrows. All right, and then array is kind of the combination of the 2. Array has 1 endpoint and 1 arrow. If it is named ray AB and the arrow's over the B, that means A gets the endpoint and the arrow goes in the direction of the B. If it was reversed, if the arrow's over the A, we would call it like ray BA, then that means the arrow's going in the other direction. So because it's unending, can I ask you what the length of array is? No. Again, where you put the arrow is important when you're naming it. The arrow goes in the direction of where the arrow is on your actual image. Opposite rays share the same middle point but point in different directions. So they have the same end point but they point in different directions. If point C lies on line AB between A and B, then CA with the arrow over the A and CB with the arrow over the B are opposite rays. They share an endpoint and they point in opposite directions. They cannot overlap. They have to share an endpoint. So I can't put a point like D here and say ray DB and ray C, well, CA. Let me reverse those letters. These are not opposite rays because they don't share an endpoint, right? Do they point in opposite directions? Yes, but they don't share an endpoint. They have to have that endpoint. And opposite rays also form a line, right? They form a straight line. Intersections. So to intersect means to meet or cut through. If you think about if you're driving down the street and you ask where the intersection is, right? It's where two streets meet. The intersection of two figures is the set of points that are in both figures. On the diagrams, and this is where geometry gets tricky because you are learning about three-dimensional things on a two-dimensional surface, right? So sometimes it's hard to even understand the diagrams. When you're looking at a diagram, if there's a dashed line, it means that if the whatever's in front of it was a solid surface, you actually wouldn't see those things. So they would be behind the solid surfaces. So if I look at this, you've got two planes, right? One's running vertically, one's running horizontally. I could say plane B is the vertical one and plane A is the horizontal one. They meet at line K, which is the line where these two planes meet. Okay. There's another line running along plane A at PQ. If this was like a solid piece of paper and I slid another piece of paper through it, this dashed area would be what's hidden behind that paper. So that's what dashed means. You wouldn't see it if you were looking from the front, okay? And these were solid figures. So a lot of these diagrams are going to have a lot going on, okay? And sometimes they're hard to follow. Anything dashed means that it would be hidden from view. All right. Now let's see what we know. I'm going to give you a couple seconds. No, I'm going to give you a couple minutes. See if you could answer these. True or false? All right, let's see how you did. Line PF ends at point P. True or false?
False.
False. Why is it false?
Because the line isn't end.
Good. 2. Point S is on an infinite number of lines. True or false? It's a 50-50 shot, guys. True. Okay. If I put a point here and I asked you each to go up to the board and draw through that, a line, could you all draw different lines? Yes. Yeah. 2 points, only one line. 1 point, an infinite amount of lines. So this is true. 3, a plane has no thickness. Nick. True. 4, collinear points are coplanar. Jonathan. If they are on, let's think about it. Like if they're on a line, right? If they're anything along that line, could I make a plane around them?
Yeah.
Yeah, so this is true. 5, planes have edges. Who didn't answer yet?
False.
False. Okay, even though the picture of them looks like they have edges, they do not. 6, 2 planes intersect in a line segment. False. What's wrong with that?
They intersect at a point.
2 planes, so 2 planes would intersect, like
No, they don't intersect.
they do, well, they could intersect, but where they intersect is not a line segment, but what? Just a line. Okay, so the word segment is what makes that whole thing wrong right there, and that's how geometry works, my friends. One little word can screw you up completely, so be careful. 7, 2 intersecting lines mean at exactly 1 point. True. Any 2 lines you draw that would meet, they would be 1 point. Points have no size. True. No size, no thickness, no dimension. And 9, line XY can be noted as XY with it, or the YX. True. The order of a line name does not matter. Rays would matter, lines would not. How many of you got at least 5 right? How about 6? 7?
Oh.
Okay, good. I won't embarrass anybody else. We'll go from there. All right, now you've got your diagram, right? So you have a horizontal plane drawn there, a vertical plane drawn, okay? The N and the M are the names of the planes. So they're not points, but the names of the planes. Everything else is a point on there except for the lowercase b. The lowercase b is the name of the line. Try to answer these. All right. Point P is in plane M. True or false?
False.
False. What plane is it in?
And
N. Good. 2, B, which that would be line B, right? Line B is in M. True. 3, line YX contains P. So YX is here. Here's the benefit of like notability and that kind of stuff. When you start to do your homework, you can highlight all over it and then erase it, right? So, let's go, Nick.
False.
False. M contains line YX. True, right? It looks as though if it's a line, it's going to extend, but so is that plane, right? So it does. I'll lose my mind if we raise hands all year. You just gotta yell out to me. I'm totally fine with it. Okay. A is on B. True. 6, A and P are in M.
False.
False. Okay. What part? First of all, P is not a point. I know P is a point on plane N. Yes. Okay. And N contains P.
True.
Good. How'd we do? Good, not so bad. Here's even the better news. Like, you're going home tonight without homework, and that is not a normal thing, so don't get used to it. Normally, we end an assignment, you have homework that night, okay? We would come in the next day. We would start it with a warm-up that reviews it. Because I'm with Transfer Kids tomorrow, you kind of get a pause on that. So tomorrow in class, you'll get to work on your assignment. You'll submit it by the end of class. And then on Monday, we'll start with the warm-up. We'll get into the next section, and we'll just keep going. Your first quiz is next. I put it up there. Next week, it's on the 25th. What is that? Thursday, yeah. And it will be 1-1 to 1-3. So we'll do 2 on Monday, 3 on Wednesday. 3 on Tuesday, and review on Wednesday, and then you'll take your quiz on Thursday. Okay? Questions for me? Okay, good.